So let's talk about order of operations as it relates to fractions. PEMDAS, that principle that you learned earlier on in the book, is still at work, but now you're dealing with fractions. So just keep that in mind. There are certain things that are important when dealing with fractions. And so let's look at a few examples here. So first of all, let's remember parentheses, you know what they look like. Sometimes we use brackets, but the idea generally in a lot of books is that you would see you see brackets and then you have parentheses within the bracket. Now, when you're dealing with exponents, if you have 2 squared, for example, that means 2 times 2. With fractions, if you have 2 over 3 and you have a squared outside, that squared actually applies to both the numerator and the denominator. So that becomes 2 squared over 3 squared. Sorry, that's a squared there. So 2 squared over 3 squared. So that becomes 4 over 9. Notice that the squared applied to both the value on top and the value in the denominator. Later on, when you get to algebra, you're going to learn about the rules of exponents and the principles that are at work in this. So just keep that in mind. Exciting days ahead as you prepare for algebra in the future. Let's look at another example. If you have negative 3 over 5 and it's squared, then that negative, by the way, will become positive because the negative times the negative is positive. And then you have 3 squared divided by 5 squared. So the negative will become positive because that squared is going to multiply with that negative. Well, that squared is going to apply to that negative. Negative times the negative is a positive. So then 3 squared over 5 squared. So that becomes 9 over 25. And that will be the answer to that particular problem. Now, here's what's interesting when you're dealing with powers. If you have 3 over 6 and there's a cubed, okay? So that would become 3 cubed over 6 cubed. And then 3 times 3 times 3 over 6 times 6 times 6. Now, we provide you with a chart that shows you in your Tools for Mastering Mathematics booklet, it shows you the value of squared, right? So you have a number, you square it, and then you take the cube, 1 times 1 times 1. You do it for 2. 2 times 2 is 4. 2 times 2 times 2 is 8. You do it for 3, 9, 27. So basically, this is the squared value, and this is cubed. So, and this is the number. So 3 times 3 times 3 is 27. So it's nice to know your square values for sure, all the way to 12, if possible more. And then for the cube value, I would say getting up to 6, just knowing that by heart is a good thing. It's a nice thing. Helps you save on time. So if you look at 6 times 6, that's 36. And then 36 times 6 is actually 216. So it's kind of nice to know that. So this is 16, this is 64, this is 25, and 25 times 5 times 5 times 5 is 125. And then 6 times 6 is 36. And then 216. Okay, so let's keep that in mind. Okay, so we have another problem here. What if we have negative 1 over 7 and it's cubed? Well, that would be negative 1 times negative 1 times negative 1 divided by 7 times 7 times 7, right? So the negative 1 times negative 1 times negative 1 is just negative 1. 7 times 7 times 7 is actually 343. So it'd be negative 1 over 343 for that one. The other way you can look at the problem is you could technically write it out as negative 1 over 7 times negative 1 over 7 times negative 1 over 7, which is true. But then again, all the values in the numerator will multiply, and all the values in the denominator will multiply. So that's how the parentheses works with the exponents on fractions. Now, when you have negative times negative times a negative, right? Like negative 1 times negative 1, you get a positive. When you have a negative times negative, so negative times negative times negative, you get a negative. So when it's an even number of times that a negative is being multiplied, so like negative 1 to the 4th power, we expect the answer to be a positive. When it's a negative 1 to an odd power, right? So let's say to the 5th power, we expect it to be negative at the end. So for the negative 1 power that has an even power, you would get a positive at the end, or a negative of whatever number. So negative 2 to the 8th power, for example. Because this 8 is even, our answer is going to be a positive number. Okay, you do 2 times 2 times 2, 8 times. But the answer is going to be positive because that negative will end up canceling out. So negative times a negative, those become a positive. You have a negative and a negative again, positive. So every time there's an even number, it becomes positive. Okay, so that's something to keep in mind. The product of an even number of negative factors is positive. The product of an odd number of negative factors is negative. The rules for order of operations are described in your book on page 312. Basically, if there's a parentheses, I encourage you to work within the parentheses first, take care of everything in the parentheses, and then take care of the exponents, and then multiplication and division, addition and subtraction. So the same principle of PEMDAS. So in this case here, we have negative 2 over 3 plus 3 over 4, and then we have that. So if you have a situation like this, basically, let's see, we can copy this to the next page. So basically, we have this situation, negative 2 over 3 plus 3/4, and then into the negative 1/2. By PEMDAS, we have to take care of the multiplication piece first because that comes before the addition. So 3 over 4 times negative 1 over 2. That's technically negative 3 over 8, right? Because the numerators multiply, the denominators multiply. So we have negative 2 over 3. That's just going to come down, negative 2 over 3. And then over here we have minus 3 over 8. We don't have a common denominator, so we have to get a common denominator. We'll multiply the top and bottom on the left side by 8 over 8 and on the right side by 3 over 3. So we have negative 16 over 24 minus 9 over 24. So negative 16 minus 9, right? So that's negative 25 over 24. So that's how we work out the problem to get to our destination. Very good. So you take care of the multiplication first before you go on from there. Let's look at another example. We have 3 into negative 1 over 3 squared minus 2 into negative 1 over 3. Okay, so PEMDAS, we see that there is exponent here. So we have 3 into negative 1 over 3 times negative 1 over 3, right? Minus 2 into negative 1 over 3. Okay, this becomes 3 into 1 over 9 minus 2, actually plus 2 over 3. What did I do? Basically, think of this as negative 2 over 1. And these two are multiplying to one another. The numerators multiply together, the denominators multiply together. Now we have 3 over 9, same thing here, plus 2 over 3. We need a common denominator, so we multiply this by 3 over 3. So we have 6 over 9, we have 3 over 9, they add together. That becomes 9 over 9, which is 1. Works out nicely in this problem. So we took care of the parentheses and we took care of the exponent, that negative 1 over 3. Notice we had to do that. And then we took care of our multiplication for each of the different sections. Like there was multiplication going on here. There was multiplication going on the right side. I apologize. That was there was multiplication going on the right side over here. And there was multiplication going on the left side. Here we're looking for a common denominator, right? Common denominator, because you can't add if you don't have that common denominator. And that was what took us to our destination. Very good. Now, what do we do when they give us sort of a formula and tell us to plug in values for A? A is equal to something, B is equal to something, C is equal to something. So here's the example. If A plus BC is the formula they've given us, or what they want us to evaluate, and we know that A is negative 1/2, B is 1/3, and C is negative 1 over 5. If we have this situation over here, then basically they want you to plug in each value, okay? So for A, we have negative 1 over 2, plus B is 1 over 3, and then C is negative 1 over 5, right? So notice that I am plugging in, this is the value for A, this is the value for B, this is the value for C. So therefore we have negative 1 over 2. Now these two have to multiply first because of PEMDAS. So that becomes negative 1 over 15. So we have negative 1 over 2 minus 1 over 15. We need a common denominator, so we multiply both the left and the right. So that one, 15 over 15, 2 over 2. So we have negative 15 over 30 minus 2 over 30. So that becomes negative 17 over 30. So basically we plugged in the value for A, we plugged in the value for B, we plugged in the value for C, and then we evaluated the situation. Right? They wanted us to evaluate, and that's what we did. Very good. So let's allow a more complicated formula now, and let's look at answer for that one. So we have AB divided by A plus B. Okay, if you have a formula like this, it's the same thing as writing it like this. Okay, AB divided by A plus B, and A is equal to negative 1/2, B is equal to negative 1/3. So let's plug in the values here carefully. A is negative 1/2, B is negative 1/3, divided by A is negative 1/2 plus B, which is negative 1/3. So now let's work step by step. So the numerator of this complex fraction is going to become just 1/6. How did we get that? Because negative 1 times negative 1 is 1. 2 times 3 is 6. In the denominator, we have negative 1/2 minus 1/3, because a positive times a negative is a negative. So we have that situation. And now we're going to proceed and write 1/6 divided by, and now we have to evaluate this. In order to evaluate that, we need a common denominator. So 3/3 on the left, 2/2 on the right. So we have negative 3/6 minus 2/6. That becomes 1/6 divided by negative 5/6. Okay. 1/6 divided by negative 5/6. Now in math, if you have A over B divided by C over D, if you have a situation where there's basically like 4 levels, this is called a complex fraction, and this is actually explained more in your algebra 2. Some in algebra 1, but it's more on, some books will put it in algebra 2. So you're beginning to learn about some complex fractions, which is very good. If you have a situation like that, you can write it like this, which is the same thing as A over B times D over C. So this is more of an extra credit type problem right now for you. Don't worry if you don't understand all of it. Just watch the video, pause, look at the steps I'm taking, and then we'll discuss it more in algebra. A over B times D over C. So this is like your A over here, this first one, and then your B, and this is your C, and this is your D. So basically, imagine if these are representing this situation. That means that A over B, so that's 1/6, so that just stays the same, times you flip the denominator, 6 over negative 5. So the 6 will cancel, and our final answer will be negative 1/5. So it is a little more, more work there, but the principle is what is used with complex fractions. So don't be discouraged. We're going to be discussing this more. There's one more example with complex fractions I want to give you before we wrap up this section. Actually, we'll do one more, and then we'll see if we can add an extra problem there before we end it. So quickly, for the complex fraction, you have 1/4 over 1/3 minus 1/3, and then 1/4 plus 1/3. So we need a common denominator, 3/3, 4/4, and then on the left, 3/3, 4/4 also. So that becomes, let's work on this one here, 3/12 minus 4/12 divided by 3/12 plus 4/12. This becomes negative 1/12 divided by 7/12. So that's negative 1/12 times 12/7. So what I did is I just flipped that over. It became 12/7. That will cancel, and you're left with negative 1/7. So that's how we work through that problem using complex fractions. Your book provides a good example of this, so I encourage you to look at the example as well. There is another way of doing complex fractions by getting a common denominator that will get rid of all the denominators. This is explained in example 8. It's a very interesting idea. Let's mention, and just a quick note on example 8 in your book, the situation where you have a complex fraction explained, but I'm using the you try it as an extra example for you. when you have that situation, you multiply both the numerator and the denominator by the lowest common multiple, right? So 30 over 30. And when you do that, you're basically multiplying each of the terms by 30, right? So imagine if you multiply each of these terms by 30. So negative 2 over 3 times 30 plus 1 over 5 times 30 divided by 4 over 5 times 30 minus 1 over 2 times 30. And then you simplify each one of these. 3 goes into 30 10 times, 5 goes into 36 times, 5 goes into 36 times, 2 goes into 30 15 times. And we have negative 20 from this part over here. And over here we have plus 6 divided by 4 times 6, which is 24, minus 15, which equals negative 14 over 9. So we use the lowest common multiple or lowest common denominator to get rid of every single part of the denominators. So now it became an ordinary fraction problem that had a numerator and a denominator. So that's a good approach to simplifying these types of problems. As far as a good application, they talk about trapezoids here in your book as they lay the stage and talk about example 9. So let's look at the trapezoid example. I'm going to look at the you try it, which is right next to example 9. Well, a trapezoid has bases measuring 6 feet and 15 feet. Those are the like call it base 1 and base 2. And the height of the trapezoid is 5 feet. Find the area of a trapezoid. So the area of the trapezoid is 1/2 times base 1 plus base 2 times height. The area of a trapezoid would be, in this case, 1/2 and then 6 plus 15 times 5. So the area is 1/2. Remember PEMDAS, so this would be 21 and then times 5. So you can basically allow the numerators, everything in the numerator, to multiply first and then divide your answer by 2. That is fine if you want to do that. Or you could, in this case, actually that's the best option because you don't have an even number in the numerator. So you just multiply them out, you get 105 over 2. And you can divide that by 2, and that's 52.5 feet squared. So that's how we find the area of a trapezoid. We go step by step. We can write it as 52.5 or 52.5. There's a lot of good practice problems for you. I would encourage you to do as many of these. You don't have to worry about the complex fractions for now, from number 57 to 68. Maybe just try one of them because you're going to be doing a lot more of those in algebra. And then I encourage you to do the trapezoid problems for sure. So for number 1 to 73, and then feel free to skip the complex fractions. So 1 to 73, odd, and then feel free to skip number 50. I believe we'll just take it from 58 to 68. You can skip those. So try maybe 57 just to give you one complex fraction example. Please email if you have any questions, and look forward to seeing you finish chapter 4. So you're almost done with it. Keep working hard and you'll be done very soon. Have a wonderful day.